One of the main benefits of aerobic exercise is the increase in cardiac output, which affects your higher maximal oxygen uptake, and it also is contributed through stroke volume. So your stroke volume and your heart rate are two factors that go together to make up cardiac output. So if we made up a little math equation, stroke volume times heart rate would equal cardiac output. So cardiac output is the total amount of blood pumped out and circulated through your system usually in a minute. So at rest, all these numbers are in males, sedentary trained and highly trained males. The reactions would look the same in females, but the numbers would be probably 25% lower. Cardiac output, this is 5 to 6 liters per minute. Our body mostly cycles through all the blood that we have in about a minute, and men just have more because in general, they have larger bodies. So cardiac output at rest is the same, whether you're trained or untrained. But what we can see over here is a big difference in resting heart rate. So when you're trained, your resting heart rate is lower, which means that overall your heart has to work less. So you get the benefits of exercise while you're working out, but also all throughout the day because your heart is working less. And the reason that happens is because through training, your body has to meet a demand of more oxygen need. And so the blood delivers the oxygen. So the demand is placed for more blood to be pumped through the body. So when you're working out, your body will pump more blood and the heart will get stronger at pushing it out. And that's stroke volume. Stroke volume is the amount of blood pumped out per beat. So the heart is a muscle and it gets trained just like the rest of our muscles. So through overload over time, your heart will squeeze harder and be more efficient per beat. So when we come down here and look at maximal exercise, so in maximal effort in an untrained person, heart rate is max. Your heart rate is dependent on your age mostly. So your heart rate can get up to 200 beats per minute in this example. But what happens is you can see there's a big difference in stroke volume. And this is the key factor that makes the total cardiac output increase. So the heart in a trained person, even though the heart is beating just as fast, it's pumping out more blood per beat. 175 milliliters here as opposed to 100 in an untrained person. And then you can see the difference in cardiac output over here. So stroke volume is the key to increasing cardiac output, and the reason is for a greater demand placed from the muscles needing oxygen to be delivered from the blood. So volume of oxygen, VO2, is how much oxygen our body is using, the volume of oxygen. So some of the same factors affect and drive our VO2. Our heart rate is going to affect VO2 because if it is higher, then we're going to be delivering more oxygen to the muscles. And that's why your heart rate increases when you begin exercising, because your muscles need more oxygen, and so it signals your heart to beat faster. That's the first response that's going to happen. You're going to see an increase in heart rate. And then over time and with training, your stroke volume will increase because your heart's saying, I'm working really hard, I need some help, I need you to be more efficient with each beat, not just increasing beats per minute. So what you'll actually see is at a certain submaximal intensity, so just like 40%, let's just say a jog, somebody who's been training for a long time will have a lower heart rate at that intensity than somebody who has just begun an exercise program, because stroke volume is significantly changed with endurance training. And then with the volume of oxygen, the amount of oxygen that's delivered to our muscles, the AVO2 difference, arterial venous oxygen difference, is a factor. That is the body's efficiency at removing the oxygen from the blood vessels, from the blood, and sending it to the muscles. So the AVO2 difference is, in short, there's an amount of oxygen in your arterial blood that's coming from the lungs to your body. The oxygen gets dropped off at the muscles, and then your venous blood that's returning to the heart is going to have a much lower oxygen content. And in trained individuals, that difference between the arterial oxygen amount and venous return oxygen amount is going to be more. Our body gets more efficient at returning or exchanging the blood oxygen to the muscles. So in our lab, we did some tests to estimate how much oxygen our body is able to circulate. And the tests that we did were the step test in lab, and then outside of lab, you did the 1 mile walk test or the 1.5 mile run test. You can do a bike test, that's the A-strand rhyming, or a 12-minute swim test. And ideally, you would do the test that most fits the activity that you're doing, because our body gets better at specifically what we train it for. So if you swim a lot, but then you do a run test, you might be under predicting your VO2 max because you're not testing it in the same way that you frequently exercise it. But in our case, it would take a long time to get everybody through the bike tests, and we don't have good access to a pool. But those tests are in your lab if you're ever curious about doing them. And a health history questionnaire we did at the beginning of the year, and that's just to screen if you have any heart or vascular issues, because under stress, which exercise is considered stress on the heart, then you could see some issues. It can be good stress, though, if it causes your stroke volume to increase and your heart to become more efficient.